Alright, welcome to 8.4, Equations of Quadratic Form. Sounds super complicated. It's not that bad. So, we're dealing with quadratic equations in this chapter, but now we're kind of extending this idea. We've been dealing with quadratic equations since, chapter 6. Chapter 5. So, instead, we're going to kind of buff it up to higher things. Then we're going to bring back some of those other kinds of equations we've been working with. We're going to bring back rationals, and we're going to bring back radicals. Not because it's something new, but because we're extending the idea. A lot of the ones we saw in the first two chapters did not end up in a quadratic form. Okay, so these ones, these will end up being quadratics, and that will make them like one more step to solve. But we're just going to kind of refresh, use it as a review chapter, kind of not lose these things for the final, review section, not lose these things for the final, but also kind of see, I don't want to say worst case scenario, but longest case scenario. Now we have some things to deal with that. We have factoring, we have complete the square, we have quadratic formula. We can use any of these to solve when we hit a quadratic. Doesn't matter how we do it. Quadratic factoring is always fastest, but as we've seen, you can't always factor. The completing the square always works, but it's really long and complicated and not everybody's favorite. Quadratic formula always works, but you always get radicals, and when you get the hard ones, it's not very fun. So quadratic formula is a good one to have in the back pocket, but it's not bad. Alright, so let's just go through these. It's not a long section, but it is kind of refresher, so it may take a little while to bring it all back. So I've got this rational equation here. I know it's rational because I have 3 rationals in it. I have 3 fractions. So the thing I want to do first is something called clearing the fractions. I want to get rid of the fractions. Let's start by clearing those fractions off. Honestly, most of this section will probably be done, for this part of the section, on your own in class, and we'll kind of review together. So I'm just going to breeze through them. I recommend you try A, B, and the next A all by yourself. Start the video by doing them on your own. Kind of remind yourself of them, and then if you can't get them, come back and watch this, because I'm going to go through this pretty decently fast. Alright, so we'll clear the fractions. This needs a 12 and an x minus 1. This one needed an x and a 12. And this one needed a 7. No, it didn't. Well, I had a 7. An x and x minus 1. Okay, so no more fractions. I've cleared the fractions. Now we have 12x minus 12 plus 12x equals 7x squared minus 7x. Combine like terms, we get 24x minus 12 equals 7x squared minus 7x. Move everything to one side. 0 equals 7x squared minus 31x plus 12. Alright, so now I'm noticing it's hit the quadratic form, right? So this is kind of where it's different from last time. We have a quadratic to solve. Luckily, we have the quadratic formula or factoring in our back pocket. You could do complete square if you felt so inclined. I'm going to try factoring. 7 would be... I'm just going to try it. I have no idea if this is going to work. We saw at the beginning of this chapter how to solve by factoring, so fun facts. 7x and 1x. Let's see, 12 could be 1 and 12. 7 plus 12 would be 19. So no, that wouldn't work. 3 times 4 would be 28. 7 times 4 would be 28 plus 3 would be 28, 29. Right, 28, 29, 30. Yeah, that would be 30. Dang it. 7 times 3 would be 21, plus 4 would be 25. 6 times 7 would be 42, plus 2 would be 43. I do not think this factors. So, I'm going to call it quits on the factoring. Nope, I don't think it factors. So, we'll go ahead and go to the quadratic formula now. Minus b plus or minus the square root. B squared minus 4 A and C all over, 2A. Okie dokie. So I'm gonna get when I try to do square roots on the iPhone, it just goes horribly right. So I'm gonna do the calculations off to the side, off the screen. But let's go ahead and do 31 squared be 961 minus 4 times 7 times 12, negative 12, would be a plus 336. So that plus 961 is 1297, which, as I concur, is not a square root. Okay. Whoops, lost that number. 1297. Okay. Sorry, I'm just double checking my math here. 12x minus 12 plus 12 on the side minus 7x squared. Okay, x equal minus b plus or minus square root b squared minus 4ac all over 2a. Yeah, okay, so 31 plus or minus the square root of 1297 over 14 is our answer. Not the prettiest answer in the world, give you that. But it works. Really? 31 squared plus 4 times 7 times, nope, 12, 625. Oh, because it's positive 12. I'm so sorry. Okay, so we're going to try that problem again. Ignore me. It's positive 12. You're probably like, Miss K, it's positive. Okay, I get you now. Because 625, I was like, how is that the first problem? Sorry, yep, I remember. Okay, so 625. And 625 is a perfect square. Woohoo! Okay, that's the perfect square of 25. So now I get 31 plus or minus 25 over 14. And so 31 plus 25 is 56 divided by 14 gives me 4. 31 plus 25 over 14 is 4. And 31 minus 25 over 14 . 31 minus 25 divided by 14. Okay, what is happening? 31 minus 25. There we go. Divided by 14. So that's 6 over 14. They both have a 2, so 3 over 7. There we go, much better. All right, so we could have factored that, which bums me out that I couldn't. So we could have factored that, but just in case, we have our our back pocket formula of quadratic formula. Okay, so let's try the next one now. Hopefully I won't drop a negative, because as you can see, that makes things go horribly awry. Here we are. LCD here. This one has no k. This one has 2 k's. And this one has 1 k. So it looks like 2 k's is all I need. K squared plus 2k equals 3. That cleared all the fractions out. Move that over. And this one I know I can factor. K minus 3 and nope, k plus 3 and k minus 1. And so k equals 3, negative 3, or k equals 1. Notice rational didn't end up in a horrible quadratic formula. Could I have used a quadratic formula? Yes, but factoring made this a 4-step problem. Not super bad. Wish I had been able to figure out the last one. I'll go back to that one. Anyway. Okay, radical. Something we've also seen in the chapter before this one. Something that will also end up quadratic. If I were to square both sides here, you end up here. And then I like to keep my a's positive, so I'm going to move everything else to the other side. Not necessarily something you have to do, but I find most people like it that way. This one also can factor into x minus 4 and x minus 2. And so we get that x is equal to 4 or 2. Solving by factoring, always what you want to do first. Okay, but we could do quadratic formula, right, and just prove it to you. X is equal to minus b plus or minus the square root of b squared minus 4a and c all over 2a. We get 6 plus or minus 36 minus 32 over 2. 6 plus or minus 4, which is 6 plus or minus 2, which would be 8 over 2, or 4, or 4 over 2, or 2. And it still worked, right? But notice that was a lot more writing. The discriminant already told me it's going to be a rational number anyways, so I don't need to do that. It's okay. Alright, so those are just a refresher. Honestly, just kind of a refresher of quadratic form, how things that don't look quadratic can become quadratic. Okay. The other thing we're going to do in this chapter is formulas, and that is arguably more important than remembering the other past stuff. As long as you remember those, you're fine. But in these ones, we end up with more formulas. Formulas we can solve, formulas we need our computers to have in certain formats. We've been through this whole idea, so we're going to go through these as well. Alright, so solve this formula, W equals KFR over V squared for V. Now recall, with any formulas, I'm basically going to put in my head a little color over. I'm going to kind of zone in on the V, and I'm going to treat everything else like it's just a number. Like it doesn't matter. It really doesn't matter. So we're going to start by, as with any other rational, getting our variable out of the denominator. I'm going to multiply v squared to both sides. And therefore it'll cancel. We end up with b squared w. Whatever. Oh, for the love. Sorry. Okay, v squared w equals kfr. And now I need to, which one am I after again? I'm after v. So I want to make sure I go after v still. So divide by w. To both sides. End up with that. And then how do I get rid of a square? We take the square root. So we get v equals plus or minus. Yes, I must have that, even though it is variables. No, I just wrote that backwards. KFR over W. And we're done. Alright, so formulas aren't too bad as long as you remember what you're doing. Remember how to solve equations. Remember that adding to both sides, multiplying to both sides, dividing to both sides, square rooting to both sides. It's all your properties of equality. But it's just you got variables there. You got letters instead of numbers. Treat them like they're numbers. Alright, d is equal to the square root of 4a over pi. Solve for a. I recommend you try this on your own and then let me know. Okay. So d, we'd want to square both sides so that we end up with 4a over pi. Yep. All outside the radical now. And then we're going to move pi over. So d squared pi is equal to 4a. Divide by 4. Oh, wow, I wrote that really far. Weird. A is equal to d squared pi over 4. Now don't be tricked. I did not move everything to the other side all of a sudden and change things around. I did divide by 4. So I got d squared pi over 4 equals a. But we normally write formulas with the things we're solving for on the left-hand side. Don't know why. People just tend to do it. Not really right or wrong. It's like 2 equals x, x equals 2. Okay, cool. This next one's a little different. This one is a little tricky because I have so I have s equals 2t squared plus kt. I have t in a couple places, and t is the thing I want to solve for. So that's a little bit of a problem for me because if there is a t in 2 places, I would wish that it was the same kind of t. One's a t squared, though, and the other one's a single t. So I can't combine them into a single t, and because of that, I can't actually separate them out. You'd think you could factor out a t, but then you still have t in two places, and it actually ends up almost virtually impossible, right? This is the same argument as this. That's a 3. What am I supposed to do here? Well, here we know that we would need to move the 3 to the other side so that we could use any of our factoring ideas and we could find out what t was. Well, why can't we just solve for t by factoring it out? Why can't we solve for t by separating it, by rearranging it? Because we know it doesn't work. That's why we've been talking about it for the last however many weeks, right? That we have 4 different methods for solving quadratics when we have 3 numbers like this, because we know we can't just solve it in the regular way. We know that way doesn't work. We have to factor it. We have to use quadratic formula. So now that I have this where it's more variables, the problem has not changed. The problem is the same. And so since the problem is the same, the solution is the same. I'm going to get everything to one side. And I can't factor this because I don't know what s and k are, but I'm going to use quadratic formula. I'll go over here. T is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And that's it. I've solved for t. So I'm using something that I knew for a very concrete scenario for something a little more abstract, right? And that's usually how these formulas are actually created. We're using something we know works and taking it to the general form so it works for everything. I can clean this up just a little bit, but I'm pretty much done. Negative k plus or minus k squared minus, plus 8s all over 4. Okay. That's one of my favorite problems because you get to see the quadratic formula being used outside of like a predefined quadratic. Okay, 2 more. This one is virtually the same as one of the earlier ones we did today. So let's go ahead and do it real fast. L equals k d to the 4th over h squared. Solve for h. Well, the h is in the bottom. That's a problem. And so we move it to the other side by multiplying, because it's dividing. I want to multiply it. And then we're solving for h. So h squared equals k d to the 4th over L. Move that L back. And then square root it, plus or minus k d to the 4th over L. Now that was, again, kind of a check your work, see if you understand it kind of thing. If it made perfect sense to you, great. If you still don't understand, then try this next one out on your own, see if you can get it. If not, come see me. Okay, so let's try this one now. F equals k over square root of d, solve for d. So move the d out, square root of d, f equals k. A lot of people think that square root's going to make it really stuck in the bottom there. It's not. It's the same idea. It's dividing by this thing, so I multiply that thing to both sides, and it goes to the other side. Square root of d equals k over f. Now, instead of square rooting both sides, I'm going to square both sides. And I get d is equal to k over f squared, or, if you prefer, k squared over f squared. And I'm done. Alright, so this is a quick section. It wasn't nearly as long as the last one, but it just kind of shows us some more things we can do with quadratics. Any questions at all, shoot me an email or come see me. Other than that, happy homework.